Good one. 1 million. 1 million? Yeah. 1 million.
Something that will change our view of reality. The first particle collisions in the Large Hadron Collider were recorded by all of its experiments.
It's obviously an incredible adventure that starts now that we really got beam colliding for the first time. You could say that the honeymoon ended a little bit abruptly last year with a week of beam we got, but we never got to the point of collisions. So obviously this year is a great moment of celebration because now we've seen the first protons really colliding in our experiment.
To me, it's a perfect proof that we have working detector, we have a beautiful collaboration which is necessary to make beauty physics. This is the main proof to me.
Each one of these experiments is looking for something, with a different method, a different strategy. Each one is trying to understand a different aspect of our universe. We will look at one of these in particular, the one on the quest to study antimatter, LHCb, the beauty experiment.
It's taken 20 years to design and build this facility. It's taken thousands of scientists and engineers to build this machine, to let us look back towards the beginning of time, when things were very, very different to the way they are now. Antimatter met in the early universe. They annihilated to release pure energy. And this energy in turn could make new pairs of matter and antimatter particles that could also meet and annihilate. And this process continued as the universe expanded. However, as the universe expanded, so it also cooled. And after about a minute, there was no longer enough energy to make new pairs of matter and antimatter particles, and the process stopped. And what remains now in the universe is a consequence of a very tiny difference, no more than 1 part in a billion, between the amount of matter and antimatter that existed at that time. We don't know why there was a difference, but we wouldn't be here if there wasn't one. Really want to understand the universe and why it looks the way it does. We need to understand antimatter and why it behaves that little bit differently.
In fact, antimatter is like normal matter, except that everything has the opposite charge. For example, the electrical charge is opposite. If we look at anti-atoms, they are made out of a negative proton and a positive electron.
So if I was made of antimatter, I would be like a mirror image of myself, with opposite charges. The tricky thing is that if matter and antimatter meet, they annihilate, disappearing in a flash of energy.
Experiments have to be analyzed on this supercomputer, on this grid. And these collaborations are formed from scientists from all over the world with different nationalities, with different cultures, with different religions and different political ideas. But still, in LHCb, like in any other CERN experiment, we share our knowledge and our experience and our efforts, and we have one common aim: to discover and better understand nature.